There's a high likelihood that you have an internal experience of the world where you see shapes in motion, hear sounds, and have other sensory experiences in what has been called the theater of the mind, almost as if there was some movie playing in your head of the world around you. But of course, who is watching this movie, and how does it now form experiences without creating some kind of infinite recursion of observers and theaters? Philosopher and articulator of the hard problem of consciousness, David Chalmers, may ask, why is the quality of deep blue different from the sensation of middle sea? What is the difference between a sight and a sound? This is the problem of qualia, and it is at the heart of David Chalmers' articulation of the hard problem of consciousness. In this video, I'll discuss precisely what distinguishes our different sensory qualia. To be clear, Chalmers is not interested in the question of why blue is not red. For all any person knows, their own experience of red is another person's experience of blue. We just know that fire and blood and the sunset share a color, while sky and peacock feathers share a color but are a completely different color from fire, blood, and the sunset. Indeed, for all we know, our own experience of colors changes frequently moment to moment. We just remember objects being the quote-unquote new color in the past after the change, so we never notice it happening. And the solution I present here doesn't circumvent the problem of philosophical zombies, whereby even our fellow humans have unprovable internal experience. In reading The Conscious Mind, I was surprised at how much of Chalmers' writing is simply acknowledging that it is in fact impossible to determine whether we are brains in jars, or other people are philosophical zombies, or whether color experience inverts in different perceivers or at different times. Philosophers and spiritualists seem so preoccupied about hemming and hawing and trying to seem deep while pondering these fundamentally unanswerable questions, while Chalmers is desperately trying to cut through all of that BS for hundreds of pages to get at the more relevant questions of why we think our thermostat is different from a house cat or ourselves. Chalmers is uninterested in these questions because they are impossible to answer, and assumes them away with his principle of organizational invariance. We must assume that brains that look similar to human brains on an empirically observable organizational level are having the same internal experience we are, and that is all we can ever say about it. Further contemplation is just a form of pseudo-intellectual navel-gazing. Chalmers and many others are interested in this question because we need to understand whether our increasingly powerful AI systems are more similar to a thermostat or a house cat or possibly humans in their internal experience. It seems very clear that the difference between a sight and a smell is due to the way they are predictively wired to our other sensory and motor neurons. See, when I tell you to close your eyes and imagine the color red, and I mean just the color red, not a red object like a sports car or a flower, not a small red box labeled red, just the color red, you probably imagine something like this. Notice it is a field of red with height and width. A visual neuron is embedded within a tight grid of similar visual neurons with a definite spatial relationship defined purely by the Hebbian learning process created when an object moves across the two dimensions of the visual field. Hebbian learning is often summarized as neurons that fire together wire together, although it is more accurate to say that neurons that fire in short temporal succession one after the other wire together, but that is less catchy. Hebbian learning captures the predictive role of neurons in the brain, each trying to predict the other on the small scale and trying to make predictions about the world as an emergent property of this micro-level prediction. You can see how physical objects moving in a visual field will cause Hebbian wiring between visual nerves. That said, there's also a role of evolution which conveniently arranges visual neurons into a grid where they don't have far to go to find their neighboring co-firing neurons. A similar combination of evolution and Hebbian wiring occurs between these visual neurons and motor neurons that control eye movement, head movement, and other aspects of body position to form a very general spatial sensorium, placing our visual sensations onto a stage with height, width, and depth. This stage is composed of trillions of latent predictions implicit in our neural connections about what you would feel if you got up and moved forward, or what you would see if you execute the motions to toss something at a target in your field of view. The air rushing over your arm. the feeling of muscles tensing and relaxing in a coordinated motion, the sight as your body weight shifts and your arm moves into your field of view while throwing, the view of your projectile as it flies along its trajectory, etc. Thus, when imagining red in your field of view, it occupies height and width. Any particular object you imagine will have very specific localization in your visual field, with implications for what happens with body movements, particularly with attention to the head and eyes. If you think of a table, its surface will be above its legs. The smell of food on the table will not give such spatial cues. In our cortex, we have an analogy that the dorsal wear pathway between the visual centers and the tactile, vestibular, and proprioceptive centers forms the soundstage of the mind. I would speculate most of this theater is in an area between the two hemispheres of the brain called the precuneus, located about here. It is between our V1 visual area and our motor sensory areas, and also has a white matter connection to the top of the lateral sulcus, where inner ear balance is processed. Let me briefly mention that I think there's a distinction between the space sense of the precuneus and the place sense of the cells in the entorhinal cortex near the hippocampus. This space sense of the precuneus is about immediate body positioning and movements, throwing an object perhaps being the best example. The place sense of the entorhinal cortex, place cells, is about planning a navigation among landmarks, so take a left at the fork and then continue on to the big rock, etc. The dorsal pathway forms a mental soundstage where we may create scenes in our mind, but we need to fill it. Into this soundstage are placed objects from the prop warehouse of the ventral what pathway that lies between the visual and auditory cortical centers on the lateral and underside of the brain. To use a video game analogy for a moment, I would speculate that the dorsal wear pathway, and probably the precuneus region in particular, is like a game engine with a physics engine that could connect the voxels in the scene's simulation space by, for example, saying the contents of a voxel that has no momentum and no blocking voxel underneath it will move into the voxel directly beneath it after some period due to gravity. The ventral what pathway's prop warehouse is like a database of assets which themselves are simply particular patterns of voxels, each of which can be loaded into the game engine's scene and then processed by the physics there. To add a little precision, I don't think these are processed as literal voxels in the brain. It is more likely to be a collection of sensory nerve patterns which can be taken to represent something like voxels in a physics engine. The V1 visual cortex at the rear of the brain is the screen onto which is projected external sensory information or internal mental images depending on how our focus allows or inhibits external stimulation of the V1 area by sensory information from our eyes. In one direction, the what pathway allows us to identify objects in our visual field, and in the opposite direction, we can recall images from this prop warehouse to place into an imagined scene. In both of these cases, our awareness is like a film made on our soundstage with props from our warehouse projected onto the screen. Just sometimes external senses rather than imagination dictate prop choice. This use of props from our what pathway warehouse is what attention schema theory is describing with the partial and not fully accurate schema employed in our awareness, and how our brain can leave a collection of pixels uncategorized by referring to the specimens in our prop warehouse to be recognized as, say, a man in a gorilla suit if our attention is on other objects in our visual field. For those that don't know, this is footage from Daniel Simon's famous cognitive science experiment where participants were asked to count the number of times players wearing white passed the ball, while at some point in the footage, a man in a gorilla suit walks through. Later, the participants were asked if anything unusual happened, and they can't recall the man in the gorilla suit. But let's decompose our visual spatial awareness using cases from brain lesion disorders to isolate the elements of our awareness. A blind sight patient has a damaged screen but may retain some object recognition and motor awareness, like playing a game without textures or shading. This Minecraft image removes textures, but even here the blue in the skybox wouldn't be visible, nor would there be shading on the blocks to give a sense of depth. There actually was a creature in this image. Did you see it? I think you'll agree it becomes more visible when we add motion. People with optic ataxia, which doesn't allow them to coordinate their hand movements with visual information, such as with Balint syndrome, have damage in their dorsal wear pathway. This patient with severe Balint syndrome, due to damage in his dorsal pathway, has difficulty grasping objects with a more affected hand, despite being able to see the objects individually. He also has dorsal simultanagnosia, which doesn't allow him to see both objects at the same time, very much like he's only seeing one object in his prop warehouse at a time because there's no stage upon which to place the objects.
Yeah.
Do you see the spoon?
Mm-hmm.
What do you see now?
I see the spoon.
What do you see now?
Coma.
Do you see a spoon at all?
Yeah.
Okay. Can you see what? Just tell me what you see.
I see what looks like a blackboard with some writing on it.
Mm-hmm. And there is a blackboard with some writing right behind us.
Dorsal simultanagnosiacs have difficulty visually navigating a room and will bump into obstacles frequently. An aphantasiac that has less ability to picture things, or an agnosiac that can't identify seen objects, likely have difficulty connecting to the prop warehouse in the ventral what pathway. Aphantasiacs have difficulty recalling objects from the warehouse to the mind's eye, and agnosiacs have difficulty in the opposite direction connecting a collection of pixels to an object in their warehouse, although there is often overlap in aphantasia and agnosia. One form of agnosia, prosopagnosia, affects specifically faces. There's a kind of face warehouse in our brain, which some viewers could analogize to the basement of Game of Thrones' House of Black and White. Losing access to that warehouse makes a person unable to categorize faces as belonging to people that they have seen before. But while our visual senses have a well-developed integration with our proprioceptive and motor neurons, the predictive relationships between our olfactory senses and our somatosensory and motor neurons are much less precise. While we may be able to get a crude directional indication from our sense of smell by the differences between our nostrils, olfactory sensory nerves within the nostrils don't have the same regularized patterns of excitation as visual neurons. Scent-triggering molecules exist in a chaotic cloud of particles which may or may not interact with our olfactory sensors. If I ask you to imagine the scent of a rose, you may associate that with the sensation of your diaphragm flexing to draw breath and the temperature and humidity on the inside of your nostrils dropping as air rushes in, but you won't have a strong indication of spatiality or place for that scent in the way that red produces a field with height and width. And this is despite the fact our brain structure for olfactory sense, the olfactory bulb, does have a dimensional spatial regularity which places similar scents near other similar scents. What is missing is a rich and precise connection to our skeletal muscles as we see with the wear pathway between our visual senses and the somatosensory and proprioceptive senses. Of course, it would make no sense to have that connection between our smell and our muscles because smell does not correspond to physical space the way our retina or visual cortex does. Our smell dimensionality only corresponds to the chemical properties of volatile molecules. So the quality of deep blue differs from the sensation of middle C due to things like the differences in precision and regularity of our visual nerves and auditory nerves. Our ears have less precise ability to locate sounds with respect to things like our other body parts as compared with vision, despite also contributing to spatial awareness in structures like the colliculus and wear pathway. Audio neurons have particular relations with other audio neurons which are much more regular than their relations to visual neurons. And similarly, visual neurons self-wire more intensely relative to their interconnections with auditory nerves. Genetic and Hebbian wiring of neurons makes these differences part of the observable structure of our brain. And that is most of the answer. I think this will end up as a series of videos, as this is far from the only thing I have to say on the topic. I also want to address the question of what produces a sense of moment in time, which itself will require a larger discussion about what defines a mind. I'll briefly mention here that you need a long series of connections to form the integration of senses I discuss, which happens in the thalamocortical loops that generate alpha and gamma waves. This is what connects the previous discussion to states of wakeful awareness and unconsciousness. I'd also like to talk a little bit about how close we are to achieving human-like intelligence with GPUs and what we'll need to do to get it. I think it's clear from the previous discussion that there's nothing particularly special about how the human brain generates our sensory qualia compared with artificial substrates, and I'd also like to address the moral questions this raises and that ultimately people are so concerned about. So if those topics interest you, please hit the subscribe button and consider sharing this video on social media. This has been Shiva's Right Foot, and I'll talk to you next time.